Welcome to VPC for non-engineers, a video focused on network isolation without the jargon. When you use AWS, your business data sits on shared infrastructure with thousands of other companies. A VPC is your private, walled-off section. Think of it as having your own locked private office instead of an open-plan co-working space. In this video, we'll cover what a VPC is, exploring subnets and architecture using a helpful office building analogy. We'll discuss gateways and firewalls, and finally, look at a simple blueprint for small business use cases. This video is part of a larger curriculum, AWS for Business Builders, designed to take you from zero to cloud ready. AWS operates a massive data center network for millions of customers. Without logical separation, all servers would be on the same open network, posing a security and compliance risk. VPCs solve this by providing every customer with a logically separate, fully controlled network environment. A virtual private cloud, or VPC, is your own private network within AWS. It's logically isolated, meaning no other AWS customer can see or interfere with your resources, even though you share the physical hardware. Your VPC is like a locked floor in an office skyscraper. You control who enters, the internal layout, and where the windows face. A VPC is logically isolated, invisible to other AWS customers, with no traffic crossing unless explicitly allowed. It's fully configurable, allowing you to control IP addresses, routing rules, and firewall settings. A single VPC can span multiple availability zones for redundancy, but each VPC is region-specific. Now, let's look at the default VPC. When you create a new AWS account, AWS automatically provisions a default VPC in every region. Think of it as your AWS starter home. The default VPC is ready immediately, requiring no setup. It's fine for development, prototyping, and early-stage projects. However, it is not ideal for production because the default settings are permissive. For sensitive workloads, a custom VPC provides better control. You should create a custom VPC if you are storing sensitive data, as it requires stricter network controls. Custom VPCs are necessary when launching production applications to ensure proper public/private separation. They are also required for compliance with frameworks like SOC2 and HIPAA and for maintaining a clean architecture. Chapter 2 is about subnets, dividing your private office into rooms. Subnets allow you to partition your VPC floor into distinct areas with different purposes and access rules. Public subnets are like the lobby, accessible to the outside world, hosting resources like web servers and load balancers. Private subnets are like the back office, accessible only to internal users, hosting resources like databases and internal application servers that should never be internet reachable. In the public subnet, you'll find web servers, load balancers, NAT gateways, and bastion hosts. In the private subnet, you'll place databases, application servers, internal APIs, microservices, and file storage servers. The golden rule of subnets is simple. If a resource needs to talk directly to the internet, put it in a public subnet. If it should never be reachable from the internet, put it in a private subnet. When in doubt, private is safer. A web server is public, but the database it queries should be private. Chapter 3 covers gateways, the two doors in and out of your VPC. The Internet Gateway is the front door, connecting your VPC to the public internet, allowing public subnets to send and receive traffic. It's free to use and analogous to the main entrance of a building. Every VPC needing internet access must have one. The NAT Gateway is the staff exit, letting resources in your private subnet initiate outbound connections, like for software updates, without being internet reachable themselves. It has an hourly and data processing cost, typically running $30 to $60 per month. Developers can skip this until going to production. Here is a quick glance at the differences between the Internet Gateway and the NAT Gateway. The Internet Gateway is used by public subnets, allows inbound traffic, and is free. The NAT Gateway is used by private subnets, does not allow inbound traffic, and has a base cost. Chapter 4 covers firewalls, the two layers of protection for your network. These layers act like security checkpoints in your virtual office. AWS gives you two firewall layers. Security groups are attached to individual resources and are stateful, meaning they remember connections. Network ACLs, or NACLs, are attached to entire subnets and are stateless, requiring you to explicitly allow both inbound and outbound traffic. Security groups are your resource-level bodyguard. They are stateful, meaning if incoming traffic is allowed, the return traffic is automatically allowed out. They are attached to the individual resource, not the subnet. Network ACLs, NACLs, are the subnet level checkpoint. They are stateless, requiring 2 rules for every connection, one for inbound and one for outbound. For most small businesses, security groups are sufficient. NACLs are primarily needed for dedicated security teams or strict compliance. Here is a side-by-side comparison. Security groups are stateful, apply to individual resources, and deny all traffic by default. NACLs are stateless, apply to entire subnets, and allow all traffic by default. For small businesses, security groups are essential to learn first. Chapter 5 discusses VPC flow logs, seeing every conversation in your network. These logs are a crucial tool for security and monitoring. VPC flow logs record metadata about every network connection, including who connected, from where, on what port, and whether the traffic was accepted or rejected. They are useful for security investigation, troubleshooting, and compliance evidence, but don't capture the actual content of the traffic. Enabling flow logs is simple in the AWS console. Open your VPC, create the flow log, and set the retention period. The main cost is storage in S3 or CloudWatch, which is usually only a few dollars per month for a small business. Chapter 6 presents your SMB network blueprint, the 2-subnet architecture. This simple, secure pattern covers 90% of small business needs. This 2-subnet architecture uses one public subnet and one private subnet. The public subnet hosts resources exposed to the internet, like a web server, while the private subnet hosts sensitive resources, like a database, that have no direct public access. Here's how the 2 subnets work together. A customer request comes in through the NAT Gateway to the public web server. The web server then queries the database in the private subnet, without the database ever touching the public internet. This architecture is secure because the database has no internet exposure, and the web server has a minimal attack surface defined by strict security groups. All internal traffic stays on the secure AWS private backbone. You can build this architecture using the VPC wizard in the AWS console. Simply create a VPC with public and private subnets, launch an EC2 instance in public, and an RDS database in private, securing both with security groups. The aha moment is when you verify that your database is invisible to the internet, but perfectly accessible to your web server. This confirms that network isolation is working exactly as designed. Let's review the VPC concepts we've covered. The VPC is your private network. Subnets divide it into public and private areas. The Internet Gateway is the public front door, and the NAT Gateway is the private staff exit. Security groups and NACLs are your firewalls, and flow logs record all connections. Avoid common mistakes. Never place databases in public subnets, and don't use allow all security group rules. Always enable flow logs for visibility, and use multiple availability zones for production workloads to prevent downtime. The VPC itself is free. The Internet Gateway is also free. The main cost components are the NAT Gateway, which costs approximately $33 per month, and flow logs, which cost just a couple of dollars monthly for storage. You don't need to be a network engineer to use VPC correctly. You need a public subnet for internet-facing resources and a private subnet for sensitive resources. Everything else is configuration details you can learn as you go. We've created a free, fully editable network diagram template of the 2-subnet VPC architecture. Use this resource for technical documentation, client presentations, or compliance evidence. The download link is in the video description. Coming up next is Module 3, Episode 4, CloudTrail and Guard Duty. We'll show you how to set up your 24/7 security watchdog to monitor all activity in your AWS account. If someone tries to break in, these services will catch it.